Hello friends, I welcome you all to this session on graph theory. So in this particular lecture, we will be solving some of the problems based on the handshaking theorem and its corollary. So before I start solving the problem, so let us quickly revise what we have learned in the last lecture, that the sum of the degree of all the vertices in a graph should be equal to twice the number of edges. And the second one, that the total degree will always be even. And the last one is that the number of vertices having odd degree should always be even. So let us start solving the first problem. It says that a graph has 5 vertices. So n is given to us as 5. The degrees of 4 of the vertices, they are 2, 3, 1 and 2. Find the degree of the fifth vertex. Let's say that the degree of the fifth vertex is x, and the remaining vertices have degree 2, 3, 1 and 2. And we know from the handshaking theorem that the sum of the degrees of any graph, undirected graph, should be equal to twice the number of edges. If you add them up, so it is x plus 5 plus 1 6 plus 2 8, and that is equal to 2 times 5, that is 10. So therefore x will be 10 minus 8, which is 2. So the degree of that unknown vertex is 2. Let's take this problem. It says that a graph has 6 vertices. So n is given to us as 6, 7 edges, so m is 7. Then what is the sum of the degree of all the vertices? So we know that the sum of degree of vertices for any graph, undirected graph, is twice the number of edges. How many edges are there? 7. So it is 2 times 7, that is 14. So the total degree of vertices in this graph will be equal to 14. Let us take this problem. This says that in a graph, the degree of 6 vertices are given to us as 1, 2, 2, 3, 3 and x, basically unknown. We have to find this x if the edges are 7. So again, the sum of the degrees, that is 1 plus 2 plus 2 plus 3 plus 3 plus x, is equal to twice the number of edges. How many edges are there? 7. So 3 plus 3 6 plus 4 10 plus 1 11. 11 plus x will be 7 2s are 14. So x will be 14 minus 11, that is 3. So in this particular case, the vertex x, so vertex that is unknown degree, will be having degree 3. Now try to solve this problem. What does this particular problem says? It says that the sum of degree of all the vertices in a graph is 24. What is this? This is sigma degree vi, I is from 1 to n, is given to us as 24. How many edges does the graph have? So we know that the sum of the degree will always be equal to twice the number of edges. So m will come out as 24 by 2, that is 12. Let us take this problem. This says that we are having a graph with 21 edges. How many edges are there in the graph? 21. 4 vertices of degree 3. So there are 4 vertices whose degree is 3. And the remaining vertices are of degree 4. We have to find the number of vertices in that graph. Let's say n be the number of vertices in this graph, and out of those n, 4 have degree 3. So how many vertices are now remaining? N minus 4. So these will be having degree 4. So we know that the sum of the degree of all the vertices in a graph should be equal to twice the number of edges. So this is 3 times 4 plus 4 times n minus 4 should be twice the number of edges. How many edges are there? Sorry, the number of edges is, the number is 21, not 7. Sorry. So this is 21. Okay. So now this is 12 plus 4n minus 16, and that is equal to 42. Therefore, 4n will be, this is minus 2, 6 minus 16, sorry, this is minus 4 minus 16 plus 12. So it is 4, and that is equal to 42. So 4n will be equal to 42 plus 4, that is 46. So n will be equal to 46 divided by 4. So n is equal to 46 divided by 4. So that will come out to be 11.5. Oh ho! Now what has happened? This is fraction. That means this graph is not possible. You know that the number of vertices in any graph has to be a positive integer, but this is not an integer. So the graph in the problem is having a problem, that is, this particular graph does not exist. So always you have to remember that whenever you are given with a problem, then while solving it, if either the number of vertices or the number of edges comes out to be non-integers, then in that case that particular graph is not possible. Okay, so let us try to solve this problem. This problem says that prove that there does not exist a graph with 5 vertices with the following degree sequence. So the sum of the degree of the graph, degree of the vertices for a graph should be equal to twice the number of edges. So if we do the sum, that is 1 plus 2 plus 3 plus 3 plus 4 is 2m. So 3 plus 3 is 6 plus 4 10 plus 3 13, and then this is m. So this is again fraction. So what can we say? That the edges can't be in fraction, hence the graph is not possible. Now this you could have also done by observing the degree sequence. Let us do that. So it is 1, 2, 3, 3, 4. So what is this? This is the sum is coming out to be 13, but in principle the sum has to be even number. So this is not an even number, so therefore this is not possible. You could have also seen that there are 3 vertices in the graph which are having odd degrees. But our corollary says that in any possible graph, the number of vertices having odd degree should always be even. But how many vertices are there with odd degree? 3. So again, this is not possible. So in every aspect, this particular graph is a non-possible graph. So now you know how to handle problems related to theorem, that is handshaking theorem. So in this video, till this point only, in the next lecture, we will be learning about Havel-Hakimi theorem to evaluate This is another approach to show that whether a particular graph is a possible graph or whether a particular simple graph is a possible case of or it is a graphical or not. It is a possible case of graph or it is a graph, simple graph or not. So thank you very much for watching the video.